Okay, question 8. So what is a mistake that John has made? Okay, mistake. Alright, so how do we work out the mistake? Well, let's read this together. Children at John's school were asked to complete a questionnaire about their sleeping habits to find out if they were getting enough sleep. The survey found that people who read a lot at bedtime slept fewer hours on average per night than people who didn't. So again, you have to be very careful about the wording here. So this is the survey finding. Now, if you guys understand anything about scientific studies, right, I don't want to make it too complicated, but just because you observe a relationship, it does not mean that one causes the other. Okay, so you might say, for example, a very common example of correlation versus causation is as ice cream sales rise, we found that shark attacks increased. So these were two directly observed trends which appeared proportional to each other, right? And you might say, oh, yep, so the ice cream sales must be causing the shark attacks, but in reality, it isn't. There's a third variable at play, which is summer, right? Summertime, people are going to the beaches, people are more likely to swim out in the ocean, so therefore the rising levels of shark attacks, and also more ice cream sales because people are buying ice cream. Anyway, I went on a tangent, but just know that just because you have an association, that does not mean there is causation, right? That does not mean that reading at bedtime causes poorer sleep, okay? So we see these two things occur together, but it doesn't mean one causes the other. So John says this shows that reading at night does not help you get to sleep. So John has made a causal fallacy because he's basically saw that this occurred, right? This relationship that was observed, and he goes off and falsely assumes causation when this could just simply be an accident, it could just be a coincidence, or there's other factors and variables at play. So what is the mistake that John has made? Let's go through the options. A, it could be that people are reading more because they're having trouble sleeping. Perfect, right? Because what John is saying is that reading, or bedtime reading, night leads to poorer sleep. But it could be people who are insomniac, people who find it difficult to fall asleep, who just lay in bed and have more time to read, right? So it could be the other way around. It's not necessarily that this causes this. It could be the other way around. Or it could be even a third variable leading to both, right? We don't know. So option A is very good because it points out that John has made a causal fallacy. He's assumed that reading causes poor sleep when we don't have enough proof to validate his claim. So A points out his mistake. If we go through B, C, D, they're not as good at actually pinpointing his mistakes. So B says it could be that people who don't read as much spend more time playing computer games. B is random. It just suddenly starts talking about computer games when that's not mentioned at all in the questionnaire. And we can't talk about any variables that weren't included in the study, right? C, it could be that some children are not allowed to stay up late reading books. Now that's actually not pointing out John's mistake. That's aligning with John's argument almost, because it's saying those who don't read at night, they don't stay up late, therefore they probably have better sleep than those who do read at night, who suffer with sleep problems. So C is not pointing out the mistake John has made, it's almost aligning with his statement, almost implicitly supporting what he's said. D, it could be that some books are more exciting to read than others. Again, it's not really pointing out the mistake, it's almost implying that John is correct because, hey, maybe these books are so riveting that kids can't fall asleep and therefore reading at nighttime does disturb sleep. So D does not point out John's mistake. You have to make sure that you're pointing out the mistake he has made. Okay, question 9. Each card in a set of 15 cards has one of 3 shapes in it: a triangle, square, a circle. Inside the shape, a number from 1 to 9. I've written no 2 cards are identical. The only number that appears in both a square and a circle is 7. Which of the following statements must be true? Key word here is must be. Okay, so there's several ways you can go about doing this. What I'm going to do is I'm going to set up a little table, and I'm just going to divide it into the different cards with square, square, triangle, and circle. So first of all, let's draw a little triangle here. So we have our triangle, then we have our square, and then we have our circle. Okay, so we know for sure that we will have a number So actually, let's just read this rule. This rule is really important. The only number that appears in both a square and a circle is 7. Okay, actually, a square and a circle is 7. So that means that 7, right? We know that there's a square with 7 in it and there's a circle with 7. We also know, just to reiterate, that there are 15 cards. Okay, so that's important to note. Anyway, so that means that for all the other numbers from 1 to 9, we don't have any common numbers between the square and the circle. So we can't have 6, 6 or 5, 5 or 4, 4. That's not possible. So let's just go all the way back to 1 because we have numbers 1 to 9. Okay, so what if we have a 1 in the triangle? That means we can have maybe a 1 in the square, right? That's possible. This is just me testing some different combinations, okay? What if we had a 2 in the triangle? And we can't have a 1 in the circle because, again, the only number that appears in both square and circle is 7. So we can't have similarities between square and circle apart from the 7. So let's just say we have number 2. We can have a 2 perhaps in the circle. So I'm just guessing again, just trialing and error. 3, let's just say we have a 3 in this triangle. We can have a 3 in the square, right? That's possible. And then we can keep continuing down until we hit the total of 15 cards, okay? So we want to hit 15 cards in total. What if we had 4 in triangle? Maybe we have 4 in the circle. How many cards do we have so far? We have 2, 4, 6, 8, 10. 10 cards. So we need another 5 cards. What if we had 5 here? We might have 5 here. What if we had 6 here? We might have a 6 here, right? We just can't have any more similarities between square and circle. Okay, how many cards do we have so far? We have 14, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for the last card, we don't know where it would be. It could be, so let's just say the last card is 8, or it could be 9, doesn't matter. It could be either here, here, or here. So, you know, we don't really have enough information, and this is all just quite tentative. Okay, so let's just go through this carefully. The key word here is must be true. So this is just one possible combination. We can also change around things a little bit, but we can kind of gauge that there's many cards in the triangle region, and that's primarily because we want to make sure we follow this rule that we can't have more than a 7 share between square and circle, okay? A, is it definitely true? No. Each shape appears on 5 cards. No, because here we have, for example, 7 triangles, and here we have 1, 2, 3, 4. Look. It's not definitely 5 for each shape. B, there are at least 5 cards with triangles. That's definitely true. That is 100% true because if you think about it, it's not possible to have less than 5 cards with triangles. Because if there's less than 5 cards with triangles, then that means there would be 11 cards given to square and circle. And that would not work because then we would have a contradiction of the rule where only one number appears in both square and circle 7. Right? As you can see, we have minimum 5 cards with triangle, so that must be our answer, option B. C and D are not definitely true. They're possibly true, but not definitely true. Let me show you why. C says there are at least 5 cards with squares. So here we have 1, 2, 3, 4. And what if we don't have the 8 here? What if we just had the 8 here? So if we had the 8 here, there would only be 4 cards with the square. And for here, there would also be 4 cards with the circle. So in this case, that disproves both C and D because it's possible for there to only be 4 cards with squares, 4 cards with circles, right? Or even less than that, respectively for both. So that just proves to us that C and D are not necessarily true. So the only answer that works is option B. Option B has to be true. And you can further experiment, right? But obviously, given we don't have a lot of time to do these questions, we should probably try to do the fastest way, which is what I've shown here. Okay, let's move on to question 10. So the way I've done question 10, and there's different ways, but what I've done is I will simply label the different zones. So I'm going to call the most center zone A, and then the one out B, C, and D, okay? So this one will be B, this one will be C, and this one will be D. So the one at the most outer zone is D, okay? This will just help us work out what's going on. Okay, so Zoe scores 8. So Zoe did 1 at A, 1 at C, and 1 at D. So we can say A plus C plus D equals 8. Right, Zoe scored 8. Bobby missed 1 and scored 4. So if you look at Bobby, we have A, B, C. So Bobby has 2 at zone C. So 2 at zone C. So 2C equals 4. Therefore, C equals 2. Okay, that's Bobby. Gabby is A plus 2B. And that gives you 11, right? So what did Hermione score? So Hermione got B plus C plus D. So we have to work out the values of each respective zone. We already know that C equals 2, so we can replace C equals 2, but we have to work out B and D, right? So let's work out B and D so we can work out what Hermione's total is. A key rule is the middle zone is worth the most points and each other zone is worth fewer points than the one inside it. So the middle zone is actually zone A. It's worth the most points, which makes sense. And then each zone is worth fewer than the ones inside. So as you go further out, it's worth less points. So we can come up with a formula that A is worth the most, right? Then followed by the next zone, B, then followed by C, and then followed by D. Now, if you were smart, you'd think, okay, so C equals 2. So if C equals 2, then what does D have to equal? Because as we know, D is less than 2, right? So zone D is less than zone C. So D must be 1, right? Has to be 1. Okay, so that's going to help us a lot because now we know that D equals 1, C equals 2. We can plug in these numbers into Zoe. So Zoe is A plus C plus D. So A plus 2 plus 1, which is equal to A plus 3, which is equal to what? Well, A equals 8 minus 3, which is 5. So now we know that A equals 5. And then we can plug that into the formula for Gabby. So instead of A, we can write 5. 5 plus 2B equals 11. So 2B equals 11 minus 5, which is equal to 6, right? So that equals 6. So therefore, B equals 3. So B equals 3. Okay, so these are the formulae that we've come up with. We worked out the values of everything. So now we can work out what Hermione got. Hermione got B plus C plus D. B is 3. D is 1. 3 plus 2 plus 1 equals 6. So what did Hermione score? Hermione scored a 6. Done. Okay, question 11. Jake and Robert are brothers. Their parents have told them they will not be allowed to go to the party tonight if they have not completed their homework. So this is a clear example of a conditional statement because we have the if. And the basic form of a conditional statement is if X, then Y. Okay? If X and Y. So if you're stuck, try to translate everything back to the basic conditional format. And then you can easily work out the contrapositive, which is basically the statement that you get by reversing and negating, which I'll show you in a second. And that is basically the same meaning as the original statement. So the contrapositive in this instance is if not Y, then not X. And if you are confused by that, let me show you why that's the case. This is just a very quick crash course on contrapositives. So if you are X, then you're Y. So if you're not in Y, so if you're not in that larger circle, which actually represents the necessary condition for being in the smaller circle, if you're not in the larger circle, then you can't be in the smaller circle. Does that make sense? Anyway, so what can we do for this? Jake and Robert are brothers. Their parents have told them they will not be allowed to go to the party if they have not completed their homework. So the format is, if they have not completed their homework, then they will not be allowed to go to the party tonight. So let's just write this out in the if X then Y format. If not completed homework, and this is not really grammatically correct, so just bear with me. If not completed homework, then not allowed to party. So you can also work out the contrapositive, which is when you reverse and negate. So you want to write it backwards and then do the opposite. So if allowed to party, then they have completed homework. Okay, so that's the contrapositive. Okay, so we just did a switcheroo between the two groups and then negated each. Okay, so this is what we have. This is just a more simplified version of what's going on. And you can even draw a Venn diagram. You don't need to do this in an exam, obviously. You only have 1 minute for the question, but I'm just doing it for the sake of explaining for you guys. So if you are allowed to party, so the smaller circle is always the sufficient condition first. So if allowed to go to party, that is, then they have completed homework, okay? That's the larger circle, so that's the necessary condition. Does that make sense? So if you haven't completed your homework, so if you're not in that larger circle or the necessary condition, then you obviously can't be in the smaller circle, therefore you can't come to the party. Does that make sense? Okay, so that's our diagram, and let's go through and analyze different people's reasoning. So we have Natalie says Jake is coming to the party, but Robert is not. So Robert can't have completed his homework. That's not necessarily true, because what if Robert has completed his homework, but he's still not allowed to the party? Because completing your homework is simply a necessary condition. It's not enough. Because maybe Robert has COVID, so Robert should be quarantining, right? That's why Robert still can't come to the party, although he has completed his homework, right? Maybe he's completed his homework, doesn't guarantee he will be allowed into the party. But Natalie says Jake is coming to the party. So if Jake was allowed to come to the party, he has definitely fulfilled that necessary condition. He's definitely completed his homework. So Natalie's wrong, because Natalie says Robert can't have completed his homework. No, Robert may have completed his homework, but still not being allowed to come to the party. But Daniel is correct. Jake must have completed his homework. Yes, right? Because if he was allowed, he must have done his homework. So only Daniel is correct. Option B. Okay. All right. We have this question. Some sets of 3-letter words can be ordered so that, and this is a problem-solving question where we have to analyze each rule. There's only one rule here, so that's pretty easy. No 2 consecutive words have any letters in common. So that means no word next to each other have common letters. Okay, so they can't have any of the same letters. For example, if you were to look at bog, does bog and cat have any of the same letters? No. Does cat and dog have any of the same letters? No. So cat does not have any similar letters to bog, nor does it have any similar letters to dog. Dog does not have any similar letters to cat, nor does it have any similar letters to met. Okay, consecutive just means next to. So words next to each other cannot have the same letters or common letters. Another such set of words is given below, but one word is missing. So we have a few issues. One word is missing and they're not in the right order. Okay, so this is pretty hard. We actually have a set of 5 words. Right now we only have 4 words, but one is missing. So we have a set of 5 words and they're not in the right order. Now, there's several ways you can go about solving this question. I'm just going to show you my way, but it's okay if you solved it a different way as well. The one thing I noticed straight away when I look at this is that many of the words have the letter A. Okay, so let me highlight that for you. Many of the words have the letter A. So of these words which have the letter A, because you can't have any words with letters in common next to each other, these words cannot be next to each other, right? So age, can, and pad cannot be next to each other. And we also know that there are 5 words. So if there are 5 words, right, 5 words, 5 positions, we know that these 3 words can't be next to each other. So therefore these 3 words must occupy these specific positions. The first, third, and fifth, they have to be separated, right? So age, can, pad, they have to be separated from each other because they can't be next to each other. And they all have A's, right? Does that make sense, guys? So I don't know the exact position of them, but we know also that cot has to be in either, let's choose a different color. Cot has to be in either the second or fourth positions. Okay, so cot has to be in either the second or fourth positions because that's just what's left for it. So you can experiment. You can say, let's just say we have cot here. Then that means the missing word has to be there. Okay, so let's just say we have cot here. We're just going to do trial and error. So let's go through option A. If cot was in position 2, then sud has to be in position 4. Now, is it possible to position the other words around cot and sud so that we follow this rule? Okay, so age. Where would age go? Age could go next to any of them, to be honest. Actually, let's choose which word would go in the middle, which doesn't share any similarities between cot and sud. So can age go here? Yeah. Can go here? No, it can't, because can shares a C. So can can't be next to cot. Can has to be all the way there. So age can go there, And then can pad go here? Yeah, perfect. We worked it out. So we know that option A works. Option A works, right? It's provided us with a viable sequence which has fulfilled this rule. And so we can move on. So just to recap, there's obviously different ways of solving this question. The one way I've used is I've just noticed that we have to separate these specific words because they all share an A. And because it's 5 words in the set, we have to therefore position them in positions 1, 3, or 5. That means position cot has to be in position 2, and the other word has to be in position 2 or 4. And then we did trial and error, and then we found out that this particular sequence works. Okay, does that make sense, guys? So when you have a question like this, which is really finicky and there's a lot going on, try to look for patterns. I think the running theme with a lot of these questions in the selected paper is pattern recognition. If you're able to recognize patterns quickly, you can come across with almost a shortcut to solving these questions because you really don't have a lot of time. You don't have a lot of time to be sitting through listing out all the possible combinations. Make sure you understand what's going on. Make sure you understand exactly the rule. So a tip is, in the exam, perhaps you can even underline the core rule and underline any conditions just to orientate yourself with what's going on, okay?